One of the challenges we're facing today is that of information overflow, and we face this problem even if we are scientists, researchers, or simple citizens. If we focus on the scientific domain, the recent statistics say that there is an average 2.5 million scientific publications that are generated on an annual basis in English only. So this creates a huge problem. This content has to be read by scientists, has to be understood, and has to be manipulated in such a way that we can generate new insights, we can extract knowledge from the existing publications, and we can generate new predictions over events that may happen in the future in the particular areas. Now, this content and this data is largely heterogeneous. It is heterogeneous in various dimensions. Data may differ in their type. You may have data in scientific publications, as we said. You may have data in news wires. You may have data in patents. You may have different types of text where data is codified. In addition, you have different domains. You have financial and banking related content and data. You have health and medicine related content and data, and so on and so forth. And if we go further in this fragmented landscape, content and data come also in different languages. As I said before, we have the scientific communities generate on average 2.5 million scientific publications in English only. Imagine the other languages. Of course, the output in the other languages is much less, but still it is there, and it needs to be processed, it needs to be understood, and it needs to be used for predictions as well. So there are at least three things that I mentioned: the type of text, the domain, the subject, and the language in which the content is rendered. Now, there are different things that you want to do with this content. You may want to extract information from this content. You may want to summarize this content. You may want to translate this content. This means that we need tools that are appropriate for each and every of these tasks and each and every of these dimensions. This is where OpenMinTeD, an e-infrastructure project, comes in. OpenMinTeD tries to do the following. It tries to develop technologies that help the researcher and the infrastructure developer homogenize content on the one side, make the content homogeneous in terms of format mainly, but also it tries to help the technology developers make these different tools that cater for different languages and different applications and different formats, make these tools interoperable so that these tools can be chained together later on to generate, if you want, new information extraction tools, new tools that can be used to process content in different ways or for different purposes. This is where OpenMinTeD comes in. OpenMinTeD is an integral part of open science. It fully endorses the open science prerogatives in the sense that, first of all, it relies primarily on the open access principles. The two content aggregators, the two content providers, if you want, that power the OpenMinTeD platform are the OpenAIRE infrastructure and the core repository. They both promote open access, and they are both integral parts of the open science ecosystem. The tools that OpenMinTeD is sourcing and is registering in its platform are also open source tools. And for those tools where we do not have the source code, the terms of use are also compatible with open science in the sense that people can freely use them, at least for research purposes. So OpenMinTeD is bound together with existing infrastructures that promote open science and is an integral part of this emerging ecosystem. The Open Science Fair was a great opportunity for OpenMinTeD and its objectives, as it enabled us to share with the Open Science Fair participants all those capacities that text mining and data mining can bring to the open science ecosystem. We had a very nice and fruitful, I want to believe, workshop that showcased applications of text and data mining in a range of scientific domains. So we had very nice talks for text and data mining in the area of life sciences, where researchers presented their work on extracting cancer pathways from medical literature. We had a very interesting talk on how one can mine information from scientific publications regarding the existence of bacteria and the development of bacteria in cheese, when cheese is produced. And then we made a huge leap in scientific terms from these life and food sciences to social sciences, where we had researchers presenting experimental work on extracting evidence of social unrest in Greece in the years of crisis in the last few years, and their correlation with political events that have been happening in the last 5 years. The Open Science Fair also gave us the opportunity to show to all the participants the functionalities of OpenMinTeD, the OpenMinTeD platform.